Today our goal is to sum up a nested absolute value summation. And let's just take a look at this special case or special index value here. Notice right here I tried to exclude explicitly I equals 0 because that leads to a division by 0, of course. So we want to avoid this, and therefore we include this condition right here, I not equal to 0. So let's carry on. Now we can rewrite this excluding 0 in this fashion. We just split it into the negative indices and the positive indices. All right. Now one thing is crystal clear. As long as I is positive, you have I minus I is equal to 0. All right. So this part's just equal to 0. That's trivial. This part here is slightly more challenging. So we need to come up with a way to find out what the value of this particular summand is. All right, so we'll have to remember the definition of absolute value. The absolute value of a number is its distance from the origin. If a number is positive, its distance from the origin is the number itself. If the number is negative, its distance from the origin is minus the value. For example, minus 5 is 5 away from the origin, and minus 5 is equal to 5. Okay, so using this definition of absolute value, we're going to get that. Let me just rewrite this. I minus the absolute value of I. And again, you call this nested because it's an absolute value within an absolute value. Okay. Now again, using the definition of absolute value, okay, if I is less than 0, which it is right here, if I is less than 0, okay, if I is less than 0, then this becomes the absolute value of I minus a minus I. And I could go ahead and simplify that right now, but I'm just leaving it that way for the sake of being illustrative here. So this is, there we go. This remains unaltered. It's just a value of I that's less than 0, so we don't change it, right? Okay, now, so this would be equal to the absolute value of 2i. We still have that all over I. And of course, nothing happened other than just saying I minus a negative I is 2i. Okay, but notice that 2i is still less than 0, right? 2i. Since I is presumed to be less than 0, 2i is certainly less than 0. Right? And so you can replace the absolute value with minus. Okay, so this is equal to minus 2i over I. But since I is not equal to 0, this is just constantly equal to negative 2, right? Which is essentially the entire problem, okay? So what we know is this particular summand is always equal to 0, and this particular summand is always equal to negative 2. Notice that there's 85 of these. Okay, there's 85 of these summands that all sum up to that are negative 2. So that's the same thing as 85 times negative 2. And let's finish it off here. So this would be equal to 85 times negative 2. Of course, that's equal to minus 170, then plus a big fat 0. Remember that part on the right-hand side is just equal to 0 since the summand is always equal to 0. So this is going to equal to minus 170, which is the answer to the problem. And that's it, folks. That's the answer to the problem. Now, and again, the problem, I won't call it trivial, but it was slightly tricky in the sense that this might have been an unanticipated result. This part's certainly easy, but the bulk of the work is just figuring out how to simplify this absolute value summand, which was done in these, 1, 2, 3, 4 steps. So we get negative 2. It happens 85 times. Result is minus 170. Thanks for viewing.